we're going to learn how to draw the parts of an atom and then how to use the periodic table to draw Bohr models of an atom. So first of all, we have to remember the parts of an atom. So the first subatomic part, subatomic means smaller than an atom because it's part of an atom, is a proton. And a proton is a positively charged particle in the nucleus of an atom. The number of the protons in an atom's nucleus is the atomic number. So inside the center of the atom is a nucleus, and in the nucleus is a proton, and we symbolize proton with P, and our charge of a proton is positive, okay? The next piece of an atom is an electron. An electron is a negatively charged particle surrounding the nucleus of an atom, and we find these on an orbital or a shell. The number of electrons surrounding the protons of an atom is equal to the number of protons in the atom's nucleus. So an electron, we'll symbolize it by E, and it has a negative charge, okay? But we also know that the electrons and the protons are the same number. So the number of electrons surrounding the nucleus of an atom is equal to the number of protons in the atom's nucleus. This is only true for the atoms that I'm going to ask you to draw today. There is another video in this lesson that does have a way that you can figure out how many electrons, protons, and neutrons each atom has in the periodic table by using the atomic mass. But we are not. We are going to use the atomic number. So the atomic number tells us how many protons there are, and then as long as you know how many protons there are, you know that the number of electrons is the same, okay? I'm going to turn that off. I know it keeps focusing. We'll just focus it one more time. There we go. Okay. So the next part of an atom that we want to look at is called the neutron. The neutron is a particle in the nucleus that has about the same mass as a proton, but no charge. So the neutron has a neutral charge, and we symbolize that with a 0. I'll just do that so that you know that it's not an O. For the atoms of the first 20 elements, the number of neutrons is either equal to or slightly greater than the number of protons. Again, the ones that we're going to build today will have exactly the same number of protons, neutrons, and electrons, okay? All right, so how do you even figure that out? Well, you have to look at the periodic table. When you look at the periodic table, you see all those squares. So this is an example of the square of carbon. And you know from our last lesson that the symbol for carbon is C, and that carbon is number 6 on our periodic table. This is the atomic number. So remember, the atomic number is the number of protons in the nucleus of an atom. So at the top, of course, this is the element name. Of course, C is the symbol, and the atomic mass is on the bottom. Okay, some periodic tables have the atomic mass and the atomic number changed, and there's a little bit different position, but always remember to look for the atomic number. We're going to draw atoms using something called a Bohr diagram. This is what a Bohr diagram looks like. A Bohr diagram is the model of an atom with the nucleus at the center. So this is the nucleus, and the electrons are going to be drawn around on different energy levels. So this is an energy level, this is an energy level, this is an energy level. And that might sound confusing, but we'll use carbon to start. So if you're looking at carbon, in order to find the number of protons, you have to know the atomic number. So the atomic number for carbon is 6. So you know that carbon has 6 protons. So we just put that in the center. 6 protons, okay? 6 protons. And if you know the number of protons, then you also know the number of neutrons, which go in the center. So, and it's equal. So we have 6 neutrons in the center. Then you have to figure out how many electrons there are, which is 6. So they're always going to be exactly the same number. You'll notice a pattern right away. So now you have to know about where you put the electrons, because the first shell of a an atom can only hold 2 electrons. The second electron or energy level can hold 8. And the third one can hold up to 18, but we're only going to go up to 8 because that's how it works. This is called the 2-8-8 rule, okay? So we have 6 protons, 6 neutrons, we need 6 electrons. So when we're actually drawing it, we need 6 protons, 6 neutrons in the center of our nucleus. And the first energy level for carbon, you can only fit 2 electrons. And you can draw them wherever. I just put a circle there and a circle there. I kind of like them even so I can see that there are 2. Well, if we've used 2 electrons, how many more electrons do we need? We need 4 because we have 6 total electrons. So I'm going to draw another energy level and I'm going to add 4 electrons. 1, 2, 3, 4. So carbon has 6 protons, 6 neutrons, and 6 electrons. I'm sorry, I wrote that goofy. So 1, 2, 3, 4, 5, 6. Remember, our protons are a positive charge, our neutrons are a neutral charge, and our electrons are a negative charge. So this is what a Bohr model of carbon might look like. Okay? So let's look at another example. Let's use our Bohr diagram of nitrogen. So if you know what nitrogen looks like on the periodic table, you know that nitrogen, it's symbolized with an N, right? Nitrogen. And if you know the atomic number of nitrogen, you know that nitrogen has an atomic number of 7. Okay? So nitrogen has 7 protons, 7 neutrons, and 7 electrons. Pretty easy, right? So our protons and neutrons go in the nucleus. So we have 7 protons and 7 neutrons. Okay, so this is our nucleus. On the first energy level, which is here, remember we can only put 2 electrons. So let's put them on there. 1, and again, you can put them wherever you want. I'm just going to balance them out because I like it that way. It doesn't really matter. Okay, then we have 5 more electrons that we have to add. So remember, this electron shell can hold 8. So can we put 5 on there? We sure can. So 1, 2, 3, 4, 5. Okay, so there's nitrogen. That's all there is to it. Okay, let's try another one for fun. All right, let's try silicon. And silicon is abbreviated Si. That's the symbol. Oops. Si is the symbol. And its atomic number is 14. So you have 14 protons, 14 neutrons, and hopefully you guessed now that there are 14 electrons. So in the nucleus of our atom, we have protons and neutrons. We have 14 protons, 14 neutrons. On our first energy shell, we can only put 2 electrons. So here's 1, here's 2. Okay? But we have to get to a total of 14. Here's where your math comes in. How many can the next shell hold? Our next level can hold 8. Remember, 2, 8, 8. Okay? So let's put 8 here. I don't know, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that one's full. So 8 electrons are here. 2 electrons are here. So we have a total of 10 electrons so far. We have to get to 14. So let's put 1, 2, 3. Sorry, this is too big. Let me adjust our camera a little bit. There we go. 4. I don't know, I kind of just like to put them in pairs. It's easier to count them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 electrons. So we have 14 protons, 14 neutrons, and 14 electrons around the shell. So today I'm going to ask you to build a couple of Bohr models and keep practicing them. Let's just do one more for fun. I'll give you a minute to draw some circles. Let's see how well we do. Let's draw magnesium today. Magnesium is symbolized with Mg. Magnesium's atomic number is 12. That gives us how many protons? 12 protons, same number of neutrons, and same number of electrons. Protons and neutrons go in the center, so we have 12 protons, 12 neutrons. We have 12 electrons, so how many go on the first shell? Remember our rule, we have 2. 1, 2. We have 10 left. How many can go on the second one? 8. 1, 2, 3, 4, 5, 6, 7, 8. So how many total electrons do we have to have? We have to have 12. Right now we only have 10, right? 8 and 2 is 10. So we have to have 2 more on our outer shell. And there you have magnesium. Cool, huh? All right, by now you should be able to figure out how to draw a Bohr model of an atom, at least for the first 18 elements.